In this video, we'll be actually looking at an example of the limit definition of the derivative. The unfortunate part about these particular examples is that they take and require a lot of algebraic work. So in this particular example, I'm going to start with finding the limit as h goes to 0 of f of x plus h minus f of x divided by h, such that this thing here is the derivative at a given point. Again, you could simply go ahead and find this limit definition and then plug in -1, which is what I'm going to do. Or you can use this example right here, this definition of the derivative, and evaluate that limit in and of itself, getting the derivative at that very specific point. So for this example, what I'm going to do is I'm going to first identify my f of x. I'm going to go ahead and rewrite so that I have my f of x plus h, which is replacing all of my x's in the problem with x plus h. I'm going to go ahead and simplify this outside of everything else, giving me x squared plus 2xh plus h squared minus 3. I'm going to take this function here, I'm going to take this function here, I'm going to plug them into this limit, giving me the limit as h approaches 0 of x squared plus 2xh plus h squared minus 3 minus x squared minus 3. This is all divided by h. Now if you recall, the way that we simplify a difference quotient, I'm going to ignore that limit for a second, the way we simplify a difference quotient is by simplifying the numerator and making sure that that h in the denominator can cancel out. Again, you'll notice that the way we want to evaluate limits is by making sure that I can plug in the h value, in this case of 0. But I can't plug in 0 because this problem child is in the way. So all the work that we've been doing up until this point has been just simply preparing us to be able to, number one, simplify the interior function. I will distribute the negative, providing this to be a negative x squared and a positive 3, which will cancel out the positive x squared. So this is the limit as h approaches 0 of x squared plus 2xh plus h squared minus 3 minus x squared plus 3. This is going to be divided by h. Now the x squared cancels out with the negative x, the negative 3 cancels out with the positive 3, and I'm left with the limit as h goes to 0 of 2xh plus h squared divided by h, which I can simplify a little bit further by factoring out h and canceling out h. So now I'm left with the limit as h goes to 0 of 2x plus h, which when I plug in h as 0, the limit can now be eliminated, and I'm left with 2x. Now again, it is extremely important that on every single one of these steps, if you start with f prime of x equals to the limit of the difference quotient, then that limit is there every time you write this equal sign, up until you've plugged the limit in to evaluate that number. So in this case, this right here is f prime of x. Again, the derivative of the function x is equal to 2x. Now, let's backtrack real quick, and I wanted to find the derivative of this function at x equals -1. So all I have to do to find the derivative at that given point is simply plug in -1.